talked about was a hyperbola. Ellipses now. Are we adding or subtracting in the equation? We are adding, okay? So you kind of have to change brain back to ellipses now. Here's the deal with translated conic sections, okay? We are no longer centered at 0, 0. Now we're centered at HK. You know this. You've seen this. But it's going to look a little different because you haven't seen it in this equation. So with the ellipse equation, remember x squared over a squared plus y squared over b squared equals 1. Now if we have to translate it, we're going to shift it somewhere. Now it's going to be x minus h squared over a squared plus y minus k squared over b squared. So you see how it's generally the same format. It's just now we have that minus h and that minus k thrown in with it. Okay, but otherwise the rules are pretty much the same. Again, we are adding because it's an ellipse. Okay, ellipses we add, hyperbolas we subtract. Here's the deal. Your a value now is a little bit different. It's the same idea, but now that we're not at 0, 0 anymore, it's going to look a little different in the end. So your a value is how far you're moving left and right. This is your distance from the center, okay? Not the origin anymore. It's how far you moved left or right from the center of your ellipse. So whatever h and k were, it's how far you moved from there, okay? Left and right. Your b value, this one's going up and down, but again, it's the distance from the center, not the origin, okay? So that's really the only difference, but it's kind of a big difference. It impacts a lot of just how you write it out. So we are going to take a look at this first one and work through it here. They tell us to graph x minus 3 squared over 25 plus y plus 2 squared over 16 equals 1. Okay. Can anyone tell me the center of this ellipse? Yeah, Aiden. 3, -2. Good job, Aiden. You switch it, right? What it looks like, you make it the opposite. It's a +3, it's a -2 because the equation is subtraction. X minus your h value, y minus your k value. So your center is 3, -2, okay? I'm going to go ahead and plot that 3, -2. Okay, not 0, 0 anymore. Now we're working from a different spot. So your a value, let's just look at the a value right now. What does a equal? A is 5, okay? Your a value is 5. That means you're going 5 to the left and 5 to the right from here, okay? What's your b value? B is 4. That means you are going 4 up and 4 down from your center, okay? So that means if we're talking vertices, first of all, how do you determine your vertices in an ellipse? Is it whatever comes first or whatever is bigger? An ellipse. We were just doing hyperbolas. Hyperbolas are whatever comes first, right? Go back to ellipses now. Ellipses come from whatever number is bigger of your a and b. So in this case, you would have won either way because the first one is the bigger one. So whichever one you chose, it would have worked. But that means our vertices are coming from here, right? Maybe you want to just remind yourself of that. This is whichever is bigger. Okay. So our vertices are coming from that 25. Okay, my a value is 5. So if you are a visual person, come on over to the graph here. If my a value is 5, that means I'm going 5 to the left. 1, 2, 3, 4, 5 from my center. Okay, so this is one vertex, and 5 to the right. 1, 2, 3, 4, 5. This is my other vertex. Okay, we said our B value is 4. So that means I'm going 4 up, 1, 2, 3, 4, and 4 down, 1, 2, 3, 4. Okay, so those are my co-vertices, which means my ellipse looks about like that. Okay, now you have options here. You could just graph it and then name those points, right? My vertices right now are 8, -2, and -2, -2. Okay, you could just do it that way. Or what you could do is take your center, and from your center, if my A value is 5, go 5 bigger than that, that's 8, and 5 smaller than that. 3 minus 5 is a -2. So you don't have to see it from the graph. You can do it right from those numbers. Just keep your A's with your X's and your B's with your Y value. Okay, that means my co-vertices, if you weren't going to do it from the graph, and I'll show you from the graph in just a minute, but if you were going to do it this way, if your B value is 4, that means from your Y value, you're going to go up 4 and down 4, right? So from -2, if I add 4, where do I end up? From -2, I'm going to add 4. I'm going to move 4 up.
2.
You'd be at a +2, right? Your X value doesn't change, so it's still at 3, and then a +2. If at -2 I move down 4, where am I now? -6, right? Again, if you want to do it from the graph, just come over here and name the points. This is the point 3, 2. This is the point 3, -6. So you can do it from looking at the graph, or you can do it from using the numbers that you have over here. They will both work, okay? Any questions on how I'm getting those numbers? Jada. The vertices come from the whichever number is bigger in your A's and B's, right? Which is the 25 is the bigger number. So that means my A value is 5. Do you like to do it from the graph, or do you like to do it from the numbers? Okay. Let me just show you here because it's easier to like show you how it works. If my center is here and my A value is the bigger one, that's going to give me vertices a distance 5 to the right and 5 to the left of my center. So my vertices are going to be here and here. So you just name those points. My vertices are at 8, -2, and -2, -2, right? My co-vertices, my number was 4. So from the center, that means I'm going up 4, that's my B value, and down 4 to get my co-vertices. And then you just name those points. This point is the point 3, 2. This point is the point 3, -6. So that's how I'm getting my vertices and my co-vertices. These guys. Does that make sense? Okay. So now your major axis length, remember major axis is the one that goes with your vertices. How long is that one, your major axis? Remember your A value was 5. You're just doubling that, right? Double your A value, so 5 times 2 is going to give you a major axis of 10, or you can just count it. It's 10 units across. What's your minor axis length? Yeah, double your 4. Double your B value, or count it, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then your foci. Do you add or subtract on this one for your foci? You're adding in the equation, so you're subtracting for the foci, right? It's always opposite. If you're adding in the equation, you're subtracting for your foci. And when you subtract, Is it going to be a squared minus b squared or b squared minus a squared? You don't really need to know that. This one's going to be, it is a squared minus b squared because it's bigger minus smaller, right? That's all you really need to worry about is go bigger minus smaller. So c squared is going to be 25 minus 16, which means c squared is 9, which means c is 3. Okay, well, if your c value is 3 and your vertices are going left and right, here's my vertices, then 3 to the left. Now here again is where it's tricky. It's not plus or minus 3, 0. Your c is 3, but your c has to come from the center. So if my center is here and my c value is 3, I'm going to go 1, 2, 3, and that's going to be one focus. And then 3 to the left, 1, 2, 3, that's going to be my other focus. So those 2 points are your foci. That's going to be 0, -2. And the other one is 6, -2. Now again, if you don't want to do it from the graph, if you know your c is 3 and you come up here to your center, right? 3, -2. If I go 3 to the left, I'm at 0, -2. If I go 3 to the right from 3, I'm at 6, -2. Okay, so you can do it from the numbers or you can do it from the graph. Questions on that? Okay. I would say this probably gets done wrong the most because you've done all the work on the other stuff and then all of a sudden people just like, my brain's done, I've found my C, I'm done. Don't forget that your C has to move from the center still, okay? Not from 0, 0. Okay, example 2. You wanna try this one on your own? We're not quite there yet? Let's do another one together. Okay, tell me your center for this one. -1, +4, right? Would be your center, -1, +4. Okay, what is your A value? 2, the square root of 4. What is your B value? 3. And are your vertices going to be on your x-axis or your y-axis? On the y-axis, because your B is bigger than your A. Okay, so let's plot this. -1, 4 is right here. That's our center. Okay, your vertices then, if it's on the B, sorry, I shouldn't have said y-axis. It's not on the y-axis anymore, but it's on the vertical. So if your B value is 3, I'm moving up 3 and down 3 from where? From the center, okay? So you're going 1, 2, 3 up and 1, 2, 3 down, which is gonna put your vertices, again, it's your B value changing. So if you subtract 3, -1, 1, which you can see with that point, right? That's -1, 1. If you add 3, -1, 7. Okay, so those are your vertices. Yeah. I'm plotting points for the vertices, yeah. So this is our center, right? -1, 4, the purple point. And our B value is 3. So from that purple point, that means you have to go up 3 and you have to go down 3 for your B value. Okay? We'll keep going. The more you do it, the better it's gonna click here. Okay, so your co-vertices, that's gonna come from your A value now. Where do you have to move for your A? Up, down, left, right? Left and right. So if your A value is gonna go left 2, 1, 2, that's 2 to the left of the center, and then 2 to the right, 1, 2. Okay? Again, you can either just name those points right now. That would be 1, 4. Sorry, that would be -1, 4. No, it wouldn't. It's +1. I'm looking at the wrong point. So 1, 4 is the pink point on the right. The pink point on the left is your -3, 4. Again, you're just going from this -1, you're going 2 to the left and 2 to the right. Okay. So that's your co-vertices. What is your major axis length? I'm just going to draw my ellipse in real quick here. Remember, your major axis is with your vertices, so that's this one. How long is that? It's doubling your B value, so that's 6, okay? The minor axis is doubling your A value, so that's 4, okay? And then your foci, C squared is going to equal either A squared minus B squared or B squared minus A squared. We know we're subtracting. It's always bigger minus smaller, so what minus what? Not 6 minus 4. 9 minus 4, yeah. So you want to take your A squareds and your B squared. So 9 minus 4. So C squared is 5. Okay. Which means C is what? If C squared is 5, C is root 5. So the square root of 5. Okay. But again, it's really tempting right now to say that my foci are at 0 plus or minus rad 5, but it's not, because that rad 5 has to move from what point? From the center. So really all you're doing is you're taking this point, because we can't actually combine that, right? -1 is going to be your x value still, and then you are going up from that 4, so it's 4 plus that rad 5 would be your y value. But then you also have to go down from that. So -1, 4 minus rad 5 would get you your other one, right? So you're dropping down rad 5 here and you're moving up rad 5 there to get your foci. Those ones are a little funky. Now you could just write that as -1, 4 plus or minus the square root of 5. Okay, so if you want to write it like this, that's totally fine. Or these are the 2 points for your foci. Jada.
What is the major axis and minor switch? I remember the first one you did.
It's all about your vertices. Remember, your major axis is always with your vertices, and your minor axis is always with your co-vertices. So because our vertices now are on the y up and down, they're moving up and down, right? Your vertices, then your major axis is vertical now too. That makes sense? So whichever axis is longer, that's your major axis. In this case, that's this one. But in this one, our longer axis was the horizontal one. That makes sense? Okay. Getting this figured out? 2 more. I'm going to do the first one with you because these ones are a little bit different again. And then I'll have you try number 4 on your own. All right, so this says write the equation for the ellipse given vertices at 2, 5 and 2, -5 and co-vertices at 0, 0 and 4, 0. Okay. I feel like these ones are a little bit easier. So if those other ones were challenging for you, give these ones a chance. Vertices at 2, 5. So you're going to plot 2, 5. That's one vertex. And 2, -5. That's the other vertex. Okay. Then it says you have co-vertices at 0, 0 and 4, 0. So our ellipse looks like this. Okay. We need to know the center to be able to write the equation. Do you guys see where the center is? It's 2, 0. Yeah, this would be your center. Here's how you can tell. It didn't change here. That's your 2. That's your x value. And it didn't change here. That's your y value. Okay, so you can always find your center without having to graph it if you just pay attention to those points. You don't have to do it that way. You may graph it. But our center is going to be at 2, 0. Okay, so that means when we write our equation, we know with an ellipse, it's always plus or minus in between our two ratios. With an ellipse, it's always plus, right? The hyperbola is minus. I know, it's hard to keep them straight. That's why I ask you a million times. Okay, so we know our equation should look like this. It's plus because it's an ellipse. But now we're shifting, right? It's 2, 0. This is our x value and our y value. So it's your h and your k, if you will, is your center. So it's going to be what first? Remember when it's plus, we always put the x first. So x where? Look back to that general form of your equation. Yeah, this right here is what we're doing, right? So x minus your h value is going to be x minus 2 squared. And then what for the next one? Y minus 0. What's y minus 0? Just y. So it's just going to be y squared. You don't need to put the minus 0 in, okay? So now here, this is a squared. This is going to be b squared, right? X stays with a, y stays with b. What is your a value? Remember, a is from center to the left or the right when we hit our vertices or co-vertices. What's your a value? Your a value is 2. So 2 squared is going to be 4. What's your b value? It's that distance, right? It's the vertical distance. So your b value, we'll go this way, is going to be 5. 5 squared is 25. So this is your equation. Does that make sense? So this is 2 squared. This is 5 squared. Okay, I want you to try this last one. Give it a go. Let's take a look. So if you plot those points, -1, 4. Come on. -1, 4. Okay, it says these are vertices, so that's a vertex. And then 7, 4. That's a vertex. And then it says you have a focus at 1, 4. Okay, if this is one focus, where's your other focus? The same distance away on the other side. So that's going to be at 5, 4. Okay, where's your center? In the middle of that, 3, 4 should be your center. So this is your center. Now let's think about what we got. We're just trying to write the equation of an ellipse. Okay, we know our center is at 3, 4. We know that an ellipse is always plus or minus in between. Plus, okay, so we know it's going to look something like this. We don't care about order with an ellipse because we're adding, and addition is commutative, so we just always put the x first on this one. So this is going to be x what? From our center. -3, yep, x minus 3 squared plus y minus 4 squared equals 1. And then we got to figure out our a value and we got to figure out our b value. Can anyone tell me a? A's the easier one.
4.
A is 4. Yeah, your a value is going from the center 1, 2, 3, 4. So your a value is 4, okay? From the center to the vertex, meaning a squared is going to be 16 if your a is 4, okay? So we got to figure out what is b squared. What's your c value? C always goes from where? Center to focus, right? If C goes from the center to the focus, your C value is 2. So we know C is 2, we know A is 4, and we're trying to find B. Now, you've got to figure out, this one is a little bit, you got to think a little bit. It's C squared equals something minus something. It's the bigger minus the smaller, okay? Is your A squared going to be bigger or your B squared going to be bigger? A squared, because my vertices are on my X, right? So that means the A squared is going to be the bigger of the two numbers. That's where our vertices are. So A squared minus whatever our B squared is. And we know our C squared. What is C squared? C squared would be 4. Square that 2. All right, so that's our setup. Now we just have to solve it. So take away the 16. You get negative 12 equals a negative B squared. Just divide by a negative 1. So B squared is 12, and that's all the farther you have to go. Put that right here. And that, my friends, is your answer. Questions on that? Do you love me for splitting this? Because that was supposed to be all one lesson, and that would have been terrible. Okay.